got some of my props here. Just give me a few seconds with this.
Is that alcohol?
Nope, not alcohol. Okay, now he's joining me today, and I'd like you to turn around. Turn the other way. One of the things that we see here is, does anybody know what this is?
Oh yeah. Oh, a nightlight.
Night lights, right? And what happens is that you probably know that there's the old ones where there is actually a light bulb, right? So that you get the hallway glowing and all that stuff. But what happened is the electrons are being excited that when they go down, they exhibit, release the energy in terms of light, okay? And heat and all that stuff. But the same thing happens with things like this. What they do is that they put a chemical that kind of reminiscent, kind of like those fluorescent minerals that you saw on those slides. And it's the same thing, that when they're excited, they'll release it back down, and that's kind of like a efficient way of having a light, like a light stand thing, so that you're not always buying the light bulbs there. Okay? Now there are some other interesting things here. Is the plasma balls. Have you played with a plasma ball before? Now, what's cool about this is a plasma ball is that, let's get your hands trapped on that thing. So remember when I said those American families were persuaded to buy that, thinking that it's going to cure cancer? They were told the electricity goes through your body and it rejuvenates you and all that stuff. But in fact, that's wrong. The electricity goes through along your skin, the largest organ in your body. Okay? Now, one of the things about this is that a regular light bulb, does anybody know how many volts is in a regular light bulb? No, those are volts. I'm talking about volts. 120 volts. Now, in a regular light bulb that has 120 volts, what's this is about 15,000 volts, okay, or 10,000 volts. And there's a lot of trapped gases that are inside here. What some people do is that sometimes they manipulate this, or they buy stun guns that are 50,000 volts. And it's quite large, okay? But 10 volts is good for us, okay? So as you press this, it's going along our skin, okay?
Would that still work if there was no, like, around it?
No, it wouldn't. So if you broke it, all the gases are gone. It can't get excited. You have to have it
electrocuted?
Probably would not work anymore. Yeah. Okay, so what I have here is... Have you seen this before? Okay. So this is one of those CFL bulbs that people are now buying because they want to phase out. They want to phase out the regular light bulbs. They're not as efficient anymore. So I'd like you to. This is what I'd like you to do. You hold it with your left hand like this, and then you're just going to touch it at the top. And we'll see if it's going to be exactly like that microwave example. Ta-da!
Takes a while to get started.
Do, re, mi, fa, la, la, da, da, da. Right, like that. Okay? So here, I'll hold it, and you can play around with that. Look at that. Right. And those are the cool things that you could do, like if you have a plasma ball, your siblings would love that stuff. And again, like, it's going through along, right? Okay, so there's that one you can play with. Try it again. Okay, so here's another one we can do. Another one we can do is a smaller version. Is this one. Here's another one. Try that yourself. Okay, he has it at the bottom. Now, try to hold it near the top. Like hold the bulb at the top instead of at the bottom. Look at that. Isn't that pretty cool? And then if you hold it in the middle, let go. There, okay? Now you hold it at the top. Okay? Now that's cool. And now let's try this one.
Don't even touch it.
Okay. Yeah, looks pretty cool there. And let me just turn this light off so that we can see that better. Now, I think there is something that we can try. and this is what we're going to do. Sometimes what you have to do is ground yourself. So we might be jumping up on the air and stuff, okay? So this is what you're going to do. You're going to put your left hand, and you're going to go like that against that plasma ball with your left hand, just like that, okay? Now at the same time is you're going to hold the ball against your palm on your right hand.
There's like 50,000 volts.
No. Okay. Now nothing happens. Now sometimes it doesn't work because we have to ground ourselves or something like that. So I'm going to see if I can jump. I don't know the sequence every time. Jump. Ah! Right, look at that. Right. Like that. Look at that. Okay, hold in the middle somewhere. Look at that. Isn't that cool? Okay, and if we let go, okay, try it again. Hold it. Okay, jump. Yeah! Alright. Superpower! Right? Look at that. Try to get closer there. Oh, right.
Can you extend it to more than one person?
I don't know. Yeah, we're having a stout. We're having a stout.
Oh, God.
What am I doing?
All right.
Jump. No, I don't know.
Charlie.
You hold that one with that one.
Get off the desk.
And I don't know.
Give it a shot.
I don't know.
Jump.
Hey, we got one.
Okay.
How about you touch the...
Oh, touch the
Yeah.
plasma ball probably.
Oh. Yeah, we just lost the first one.
Oh, okay.
There you go.
See, I don't know the science of how to transfer. We might need more bolts.
Yeah.
That wasn't holding the end.
Ah!
Hey, there you go. We got that one.
Okay. Yeah. I don't know. Okay, round of applause for this.
Nice work.
Okay. Now here is the second demo that I'll do. We'll get you to move down a bit. Okay. Now, as you can see, that there are a lot of gases or elements or compounds that can get excited by electricity, but there are some that are excited by different types of light. And one of the things I can show you is this thing right here. What I have is, what is this?
Tonic water.
Tonic water. Now, nobody really drinks tonic water, right? Like, terrible, right? Sometimes they use that to mix drinks, right? Yeah. So why do people still sell, why does this company still sell tonic water? One of the things that, even though it looks clear, is that there's a chemical that they put in there that starts with a Q. I'm not sure if you can see it there. Q.
I think it's just the
Quinine.
Quinine?
Yeah. Now, the thing about quinine is that it's used to fight malaria back in those days. So what they would do is that they would put it in water, and when you're traveling to South America, Africa, or South America or Asia back in the 70s, to fight malaria, you would drink this stuff, okay? Now, this is still around today. They put small traces in it, but it doesn't kill you. What's interesting about quinine is that it actually fluoresces under different types of light. So in the light right now, you don't see this thing glowing. But what's interesting is that it does glow under not UV light, but under black light. So let me show you how this works. So here is black light. And not good to always stare at it directly. Okay? So there it is, there. Now, look what's going to happen when you put any tonic water that you buy at a grocery store, and look what's going to happen.
You don't want to drink that.
Okay? And this is what people do when they have birthday parties or they have rave parties or anything like that. They instead of glow sticks that only last so long, they will use tonic water, and the quinine is fluorescing. Okay? And this is what they do at nightclubs. to save cost, they would have a lot of tonic water on the ceiling, and they would have black lights there. Now what some students did in grade 12 for the grad dance marathon is that some students bought some, and they put a bit of food coloring in there, and look what happens. One,
Oh, that's so pretty.
two,
I like the blue and the green.
Yeah.
that one. And there's there's that. And that's what you can try out on the weekend there.
Food coloring and black lights.
And a black light. Do you guys like that? It's pretty good. Round of applause. Thank you very much. Round of applause for this guy.
Cool.
Thank you.
You gotta hold a little bit higher up. There you go. You got both of them. Oh, sorta.
Is my background still on?